Hello everyone, welcome back to the channel. Today we are going to learn something new in maths which will make maths so much easier. Divisibility rules. These rules help us to check whether the number is divisible by any other number or not. Without further delay, let's start with the rules. Let's see the first divisibility rule, that is divisibility by 2. Suppose if I want to check any number whether that number is divisible by 2 or not, what I have to do is I have to see the digit at ones place or units place, ones place. If this number is even, the last digit is even or multiple of 2, then the whole number will be divisible by 2. For an example, if I see 128, I can see that this is an even number as its last digit is what? It is a multiple of 2. Hence, 128 is divisible by 2. So here, without doing actual division, I can say that this number is divisible by 2. Suppose I have a number 37, but as you can see, the number here is an odd number, which says because of this reason 37 is not divisible by 2. I hope you are clear. Let's move towards the next divisibility rule. So now the next divisibility rule is to check divisibility of any number by 3, right? So here what I have to do is first I have to see the number. Then what I have to do is I have to add the digits of this number. In this case, see here 7135. So here I am adding 7 plus 1 plus 3 plus 5. So let's calculate the total of it. 10 plus 1 11 plus 5 16. See, this number is not divisible by 3, which implies this whole number is not divisible by 3. Let's see the another number. Here I have a number 1236. So let's add the digits of this number. Here I am adding, and let me tell you, 1 plus 2 3, 3 plus 3 6, 6 plus 6 12. You can see here this number, it divisible by 3. That means it's a multiple of 3, which implies this whole number is divisible by 3. Yes, like this. So let's check the divisibility rule of 4, that is how we can check the divisibility of any number by 4. So in that case, what you have to do is you have to see the last two digits. If this is divisible by 4, if this is divisible by 4, then the whole number is divisible by 4. So in this case, 40 is divisible by 4, then which implies 6540 is divisible by 4. Let's see the another example, 17728. Here the last two digit is, here the last two digit is 28. So 28 is divisible by 2. Divisible by 4, which implies 17,728 is also divisible by 4. So moving ahead with our next divisibility rule, divisibility by 5. So this is one of the simplest divisibility rule. If I want to check any number whether that number is divisible by 5 or not, we have to see the last digit only. If the number is divisible by, see, if the last digit is either 0 or multiple of 5, then that number is divisible by 5. So in this case 5, so 105 is divisible by 5. If I see Let's see the another example, 1766510. So basically what I have to see, just a last digit. If this is 0 or multiple of 5, then the whole number is divisible by 5. So in this case the whole number is divisible by 5 as it ends with 0. So in the next divisibility rule, we have to see whether the number is divisible by 6 or not. So first, what is the divisibility rule of 6? To be a number divisible by 6, that number should be divisible by 2 and 3. So earlier we have seen both the rules of divisibility rule of 2 and divisibility rule of 3. So by example, we will understand how to see whether the number is divisible by 6 or not. So here what happens, the last digit is 4. So 34, it is divisible by 2. Right? But 3 plus 4 is 7. Not multiple of 3. That is not divisible by 3. So both we have to the number should be divisible by 2 and 3 both, but in this case this number is divisible by 2 but not by 3. Then what happens, then it says that this whole number is not divisible by 6. Let's see the another example of it. The another example is 924. As you can see, this is an even number, so it is divisible by 2. By 2. Right? Now let's see the sum. 9 plus 2 11, 11 plus 4 15. Definitely it is a multiple of 3, which implies it is divisible by 3. As you can see, it is divisible by 2 and 3 both, which implies this whole number, that is 924, is divisible by 6. So here we are moving ahead with the divisibility rule of 8. For this, what we have to do, we have to see the last 3 digits of any number. We have to see the last 3 digits. So in this example, if you see 016, here 016 means what? 16 only, na? So 16 is divisible by 2. If the last 3 digit is divisible by 8, divisible by 8, last 3 digits. If this is divisible by 8, then in that case the whole number is divisible by 8. So we don't have to divide the whole number. We have to just the last 3 digits. If that 3 digits are divisible by 8, then the whole number is divisible by 8. Then the whole number will be divisible by 9. So here I have taken a number 639. So 6 plus 3 plus 9 is 18. 18 is divisible by 9, which implies this whole number, that is 639, is also divisible by 9. Let's see another example of it. So got it? Again, divisibility by 10 is the one of the simplest way. What I have to see, if the last digit is 0, only 0, last digit is 0, then that number is divisible by 10. For an example, I can say is 13570. Just I have to say this 0, the last digit. If this is 0, then it is divisible by 10. One of the simplest rule. So we are at the last rule, divisibility by 11. Here what happens, the majority of the times we face problem, and for us also it is like how to check whether the number is divisible by 11 or not. So this rule involves adding and difference, that is subtraction. both the things are involved here. What I have to do, I have to alternatively add and then I have to get the difference. So alternatively means this 1 plus 1 and this is 2, right? So what I'm going to do is not right here 1 minus 1 minus 2. So here what is happening, 2 minus 2 it is 0. So if a number is 0 or multiple of 11 or divisible by 11, like that you can say. The multiple of 11 means what, 11, 22, 33, like this. If I get the difference as 0 or multiple of 11, then the whole number is divisible by 11. So in this case 121 is divisible by 11 because the sum of alternative digits, when I get the difference is 0. Let's see the another example, 4956. So alternatively add and then we take the difference. So it's like 4 plus 5 minus 9 plus 6, or 9 plus 6 minus 4 upon 5. So the order here is not important. So here what is I'm going to get is 9 minus 15. So 15 minus 9, I will get the difference 6. Again I'm telling you order is not important here. The difference what I am getting is important, positive negative nahi. So if the difference is 6, here the difference is 6, so this is not multiple, sorry, it is not divisible by 11. So I hope you understand the divisibility by 11. What I should have, I should have either 0 or multiple of 11. Whose multiple of 11? When I take the sum of alternate digits and find the difference. If my answer is 0 or multiple of 11, then only the whole number is divisible by 11.